Okay, so we know that matter consists of three states. We have solids, liquids, and gases. And solids, liquids, and gases are different states of matter. So let's take, for example, an ice cube. An ice cube is a solid. If we melt that solid, it will become a liquid. And if we heat that liquid, it will become a gas or a vapor. What we have to do is let's look at the molecular structure of solids, liquids, and gas. That's what the little tiny particles are that make up matter. And I like to look at it in terms of a chart. Okay, so if we have a chart, and up here we put solids, liquids, and gas. Okay, and if we look at the molecules of each of these, we will see that in a solid, the molecules are very tightly packed. Okay, this is like going to a party that has so many people in it, you couldn't even fit inside. So we couldn't add another molecule to that. So that's what a solid is. The molecules are tightly packed. Okay, if we have a liquid, the molecules in a liquid are actually a little looser. They're a little bit less formally associated. So if you went to a party, a liquid party, you could get in. It wouldn't be so tightly packed. So a liquid is loosely packed. And then the molecules in a gas, well, you wouldn't be able to find that party because they're so scattered, they're so excited, they're bouncing around, and you would never even be able to find the party. So we'll call those scattered. Okay, now the next thing that we want to talk about is whether each of these has a definite volume. Does the volume of each of these stay the same? And what we call that is defined. Is it a definite or defined volume? So that's the amount of space it takes up. Does it take up the same amount of space all of the time? Well, if you think of a solid, let's take, for example, my pen. My pen is a solid. All of the molecules in it are tightly packed. No other molecules can get in. The party is so packed it's closed off to any new molecules. And the amount of space that my marker takes up is the same. Whether I put it in this room, or I put it inside of a box, or I take it to the next room, it will always have a defined volume. So solids take up the same amount of space no matter where they are. Okay, liquids. Think of a liquid. If you take 6 ounces or 100 milliliters of water and pour it into a bathtub, you will still have 100 milliliters of water. So the defined volume is also the case with liquid, because no matter where you put it, it will still have that same amount. Now, gas, on the other hand, does not have a defined volume because it just fills up whichever container it's put in. So if we took a balloon and transferred the gas to a huge bucket, the gas would just take up the space inside of that huge bucket. So it does not have a defined volume. It just fills up whichever container it goes into. Now, the next thing we want to look at is defined shape. Does the item have the same shape no matter where you put it. That's what defined shape is. Okay, and let's look at my marker again. This is a great example. This is a solid, and it has a defined shape because it's always going to have this shape no matter where you put it. Liquid, on the other hand, takes the shape of the container that it's in. If you put a liquid from a cylinder into a round container, it will become the same shape as the container. So liquids do not have a defined shape. Gases, similarly, will take on the shape of whatever container they are put in, so they will not have a defined shape.